So here is the truss, as you can see. The joint where the force will be applied is this joint here, and a spring is used to calculate the force in the spring. So this way we can calculate the force in the member. Okay, so as you can see, this is the member, and then the initial length of the spring is 4.7 centimeters, where we're gonna use the F is equal to kx formula to calculate the force in the spring, which is the same as the force in the member. So now the force will be applied in the member. Okay. So as you can see over here, the extension is about 8 centimeters, and the weight and the force, the weight is 1.6 kgs, which later which will be multiplied by 9.8 to calculate the force in newtons. So the second member that I'm going to calculate is this member here. As you can see, the spring is applied. Now the load will be applied. So as you can see here, it's applied here. As you can see, the weight here is 0.22, and extension here is can be seen as 5.7 centimeters. So after having measured the change in displacement, as you can see here, we use this formula F is equal to kx to calculate the forces. The value of k, which is the spring constant, was found by another experiment where we applied the load and calculated the k, which is 3.06. Then we applied it into the equation where it says 3.06 k, which is the k, multiplied by the change in displacement, which is 8 minus 4.7, and finally we get 10.09 newtons for force in the member BK. Same was done for the force in JK, and the final force here shows is 3.06 newtons. Okay. So now this is task 2, where we need to go. The main objective is to experiment with different bases and to compare the transverse displacement of each base. So the two bases we're going to use is this base, which is the initial base, which has the cross-sectional area is about 0.6 times 0.6, and the second base is here, as you can see, which is 1 centimeter times 1 centimeter. Okay, so now first thing we're going to apply the load on this one, which is in the middle, in the center of this base. So a load of 5 newtons will be applied, which is around 0.5 kg. Okay, now the load will be applied, 0.5 newtons. Approximately 0.5 newtons, and the area will be marked. Okay. Let's see, now we're going to measure how much centimeters it is. Okay, as you can see here, it can be seen that the measurement here is around 1.9 centimeters, and that's all for here. Now we're going to experiment with the thicker base, larger cross-section area. You can see here. So now a larger cross-section area base. Okay. The load will be applied at the same area. And now again over here, the load of 5 newtons will be applied. Okay, it's around 5 newtons. going to mark this spot. Okay. Now after marking the spot, I'm going to measure this area, which is, as you can see over here, it can be seen that the measurement is around 0.6 centimeters. Actually, no, 0.5 centimeters. Okay, and it can be seen that the thicker base, which is the base with the larger cross-sectional area, is better compared to the smaller one, as you can see, because this is due to the moment of inertia. The thicker base has a larger moment of inertia, and therefore it is better to use this one, as it can hold a larger load compared to the smaller one.